Hello again. In this video, we talk about radicals some more and we discuss some properties of radicals using some examples. We are going to try to figure out what is the square root of 4 times 16 and compare result to the square root of 4 multiplied by the square root of 16. The square root of 4 multiplied by 16 is the square root of 64, which is 8. On the other side, the square root of 4 multiplied by the square root of 16 is 2 times 4, because the square root of 4 is 2 and the square root of 16 is 4, and your result in either case is the same, 8. Then, what is the square root of 16 divided by 4? And we compare that to the square root of 16 divided by the square root of 4. The square root of 16 divided by 4 is the square root of 4, because 16 divided by 4 is 4, and the square root of 4 is 2. On the other side, the square root of 16 divided by the square root of 4 is 4 divided by 2, since the square root of 16 is 4, and the square root of 4 is 2, and 4 divided by 2 is 2. So in either case, the results are also the same. Now, what can we say in general about situations like the one that we have just described? Well, what this means that in general, the nth root of a product of two real numbers, a and b, is the same thing as the nth root of the first number multiplied by the nth root of the second number. And if your real number is a fraction, like a divided by b, then the nth root of a divided by b is the same thing as the nth root of a divided by the nth root of b. We are going to use this to look at some examples. Look at the square root of 12. This is an example of what we call an entire radical. We want to rewrite this radical. We want to simplify this radical. What we need to do is break up 12 into its component factors as follows. 12 is 2 times 6. 12 is also 4 times 3. 12 is also 12 by 1. Which of these component factors is appropriate to replace 12 with under this square root sign? The one we want is the one that has a perfect square in it. So one of those factors has to be a perfect square. In other words, it is a number that if you take two whole numbers and multiply them together, you will get that number. So you have 4. The one that has a perfect square there is 4 by 3, because 4 is 2 times 2. So we can replace 12 with 4 times 3. If you look at this closely now, you will see that it looks like our formula, nth root of a times b, which is the nth root of a multiplied by the nth root of b. And you can see that, if you compare them closely, you can think of 4 as a and 3 as b, and your n is 2, even though you don't write it, it's a square root. Using that same formula, we can break up square root of 4 times 3 into the square root of 4 multiplied by the square root of 3. And since the square root of 4 is 2, we can simply write our result as 2 root 3. This is a mixed radical and it is in simplified form. Let us reverse what we just did. Let's see if we can go from this mixed radical back to an entire radical. So let's see if we can work with 2 root 3 and take it back to where we came from. Since you are multiplying 2 by root 3, what you have to do is write 2 as a number under a square root radical. For 2 to be under a square root radical, that means you have to square it. That means 2 is the same thing as the square root of 2 squared. That is, the square root of 4 is 2. And you are multiplying that by square root of 3, which is the same thing as the square root of 4 times the square root of 3. Your result looks like the same thing, that formula we used before, and you can simply rewrite it as square root of 4 times 3, which is the square root of 12. That is the entire radical we started with. So you can go forward using an entire radical and go to a mixed radical. That will be in simplified form. And you can go from a mixed radical back to an entire radical. Let's look at another example, but now let's see if we can do a cube root. The cube root of negative 40. This is an entire radical. The same thing we did previously is what we have to do here. We have to break negative 40 down into its component factors. Negative 40 is negative 20 times 2. Negative 40 is negative 10 times 4. Negative 40 is also negative 8 times 5. Which one of these gives us a perfect cube as one of the factors? You will see that it is negative 40 equals negative 8 times 5, because negative 8 is negative 2 times negative 2 times negative 2. So we can replace our radical with the cube root of negative 8 times 5. And again, if you compare that radical to our formula that we introduced earlier on, you will see that they look alike. N is 3 in this case. You can think of A as negative 8 and B as 5. And we can simply break up that radical according to our formula. And we'll be taking the cube root of negative 8 times the cube root of 5, which will just give us negative 2 times the cube root of 5. So we have simplified that radical. It is now a mixed radical in simplified form. Let's take another example. Let us see if we can now go back to where we came from. We start with negative 2 times the cube root of 5, which is a mixed radical. Because you want to write negative 2 as a cube root, that means it has to go under the cube root sign. And this means you have to rewrite negative 2 as the cube root of negative 2 cubed. In other words, it is the cube root of negative 8 multiplied by the cube root of 5, which you can see looks like our formula again. And you can go from there to bring both of those two factors under the radical. It's the cube root of negative 8 times 5, which is the cube root of negative 40. That's where we came from. What if your radicand is a fraction, like 45 over 64? What is the square root of 45 over 64? Well, from what we did previously, you can see that our formula resembles what we have here. You have the nth root of a divided by b, and you can break this up into the nth root of a divided by the nth root of b, in which case you are doing the square root of 45 divided by the square root of 64. The square root of 64 is 8, but the square root of 45 you have to break up according to our formula into its component factors, where one factor is a perfect square and the other one can just be any other number. In this case, it is 9 multiplied by 5. And you can use our formula to break them up further into the square root of 9 multiplied by the square root of 5. Your result is 3 root 5 over 8, which is the same thing as 3 over 8 multiplied by root 5. That's a mixed radical, and it is in simplified form. So, why don't you try this example? So once the question appears on the screen, like we said previously, or we did before, please pause the video and try your hand on these examples. And when you are done, you can restart the video to see what I have done. So you go ahead please and pause the video now. So what did you do? Well, here's what I did. Here are the questions, and you can see square root of 20. Like we said, we break that up into a perfect square and another number, so that would just be 4 and 5, and the result is shown 2 root 5. Cube root of 54. You want that to break that into a perfect cube and something else. So the perfect cube you want is 27, because 27 is 3 times 3 times 3. And once you break that into 2, then you have 3 times the cube root of 2. And then you have the fourth root of 80. You want a perfect fourth for that one, which is 16, because 16 is 2 times 2 times 2 times 2, 4 times. So the fourth root of 16 is 2. Your result there will be 2 times the fourth root of 5. And in the second part, you want to change a mixed radical into an entire radical. You have 3 root 2, and since it's a square root, you want 3 under the square root, which will be 9. And then using our formula that we used previously, you will just have square root of 9 times 2, which is the square root of 18. Similarly, for 4 times the cube root of 2, you want 4 under the cube root. That means you are going to cube 4, which means you are going to have the cube root of 4 times 4 times 4, which is the cube root of 64. And then using our formula again, you have the cube root of 64 times 2, which is the cube root of 128. And finally, you want the 2 times the fourth root of 3. Since you want 2 under the fourth root, that means you are going to have the fourth root of 2 multiplied by itself 4 times, which will be the fourth root of 16 times 3, which is the fourth root of 48. This concludes our video for part 2 of radicals.